Hello and welcome to episode 7 of TGIK. Can you all hear me? Because I've had people complain about my microphone lately and I want to make sure it's still good. So let me know if everything sounds good and you can hear me. Today, the plan is that I'm going to be coding up a, let's see, hello everybody, hello Vladimir, Jim. Great, okay, it's good. All right, Andy says it's all good. All right, so today we're going to be coding up a controller for Kubernetes. And I think, part of what we're going to be starting with is what a controller is. I did a bunch of scaffolding. I'll go through what I have with the scaffolding, and then we'll start writing some code and we'll see how things work. But first, the beer I'm drinking today, I'm drinking the Fremont Summer Ale. This is a local brewery here in Seattle. Just down the street from the Google Seattle office, and so during the summer we used to always take off and go there, so that's fun. And it's always more fun to code with some beer. That's just, it's my opinion. Not everybody agrees. So why don't we go ahead and get started, and I will, let's see, and again, as always, if y'all have questions, if something's not clear, if you can't see things, let me know. So the first thing I want, if you want to play along at home, feel free to do this, is I have this repo, and it's github.com/ here, I'll put this in the chat. And I'll put it in the show notes afterwards also. Oh wait, does the link doesn't show up on the screen there. Okay, that's fascinating. Probably have to muck with the CSS there. So it's github.com/ Joe Beda / TGIK -controller. And this is some scaffolding that I put together, stealing some stuff from Andy's blog post here that's linked off of here, which is like how to get the client Go dependency set up. Oh, and then you can see our really cool logo that Ashley drew for us. Thank you very much, Ashley. We love that logo. We're going to be making stickers. And yeah. Ed, did you have a question? You're just trying to see if icons show up? And so there's that. And then Andy's also putting together a blog post that goes into some more detail on how to write a controller with CRDs, which is really interesting, including how to generate a bunch of the Go client library stuff for your particular CRD. So that's going to be coming. I don't know if it's going to be a blog post or if it's going to be docked someplace, but we're going to get that out there at some point. So I borrowed some stuff from Andy there. And then we also have here a makefile that Tim Hawken put together to make it really easy to build really slim Golang Docker containers. And so we're going to be using that together. So I brought all that stuff together, and this is like a super duper simple starter kit. And I'm going to start, I'm not going to go into the code yet. I'm going to show you how this thing works. So I can do a go build star.go here, and I'm going to run it from my Mac here. And can you all see this? I'm going to make it a little bit bigger, because why not? There we go. All right, so this thing is running here. So now I have a binary. Actually, let's do that, and we'll do go run star.go. Hi, Marius. All right, so what this actually did here is this reached out to a cluster that I'm running already. And I'm running one of the, I'll show you the cluster. I'm running one of the Heptio quick stack clusters, which is a CloudFormation template. And so, yeah, so you can see, let's see, do they have the inputs there? I don't know. So we've done this in previous episodes. So, you can go to the Heptio quick start, and I have links off of the YouTube page also. But I brought up a cluster in AWS. There's nothing running on that cluster. And I ran this, and what it does is it actually goes through and shows all of the pods that are running in this cluster. So now, and I always have to find the right thing because I can't remember the split horizontally, right? Okay. So now what I'm going to do here is you can see that's continuing to run up here. Everything's synced up. And let me, oh, now I have to go cd source, go source, GitHub, Joe Beda, export cube control equals, it's cube config, not cube control. It's always this game of, can I catch my own mistakes before the latency catches up and you all catch them for me? All right, we see nothing's happening there. Last time I did was this like Python hello thing. We'll do this. Okay, so we'll run a single pod here, quard pod, and you've seen me do this before also. And what you'll see is that we saw come through here an on add, and then an update, an update, an update. And so what happens is this controller is sitting in the background. It's running on my machine locally. It's talking to the Kubernetes server, and it's saying, let me know whenever you see anything happen with any pods. And right now, hey, Michael, right now, whenever we see something change, it just logs something out, right? And so what we saw is that we got an add because I went through and I submitted this new pod into the default namespace. And then we got 3 updates. And so these updates, and you know, we can break it down and actually do a diff and stuff like that if you want to get really fancy. But essentially, I think, you know, I'm guessing like one of these updates is the scheduler scheduling the thing. Another update is the kubelet then reporting status as the thing actually gets, you know, the image gets pulled and then it gets run. And so every time that object changes in any way, whether it's added, updated, or deleted, we actually see the controller, the piece of code that we're going to look at, gets notified of that, and then we can start acting on that. And that's basically what a controller is. A controller is something that watches Kubernetes resources and then does stuff on it. So now let's go through and delete this thing. Kube control, delete, pod, quard E. And you can see that we see some updates as we tear it down cleanly, and then you see the delete there. So this is bare bones controller. This is kind of as simple as it gets. So let's take a look at the code and see what it looks like to actually get to the point here where we actually get these notifications and we can start doing some fun stuff. So I have two files here. So I have, and they're poorly named, so I might want to change that. But I have this TGI controller.go, which is really the main function. And then I have this controller.go, which actually holds the real code that we're going to be looking at. So let's go ahead and start with the main function. We'll walk through this. Again, if anybody has any questions about how this stuff works, let me know. The biggest thing that we're pulling in here is stuff that's part of the client Go library. And so this is the Golang client for the Kubernetes API. And the Kubernetes API is actually relatively straightforward. It's a simple REST API for getting and listing and doing all sorts of stuff with these things. When you start using the Go client here, you get a bunch of extra stuff along with it. And so it's actually ends up being, okay, so Glycon, I'm probably pronouncing your name wrong. Glycon asks, can you have more than one controller watching the cluster at once? Yeah, so like a lot of controllers are watching, they're dealing with stuff. They might be, you want to avoid having 2 controllers trying to do the same thing at the same time because they can fight against each other. And that's probably a more advanced topic of how do you actually run something like this in a high availability mode. One of the things that you can see, though, is that these things, if you write them the right way, they're really resilient to being restarted. And so it's not as critical. It's not as critical to actually get it, to have these things high availability, because if they restart, they can usually pick up where they left off. And then Ruben's asking, do controllers have to be written in Go? No, they don't. But it turns out that a lot of the stuff that comes along with the Go library is way ahead of what you're going to find for libraries for other languages. And so if you can hit the API, it's REST, it's a wire thing. There are some places where it's under-documented where we need to do a better job. But you can write a controller to go ahead and do that stuff. But okay, so here's what's in the Go library, and it might be worthwhile. I'm not going to spend a ton of time sinking into that, but you have the first thing you can do is there's this kubeconfig file that stores like how to connect to Kubernetes, connect and authenticate to Kubernetes clusters. We've seen that before. You've seen it if you've used Kubernetes. I'm not going to show it on screen because it has my secret keys in it, and they're secret. Secret keys are secret. And so it knows how to parse those and actually, do stuff with those. It provides some type-safe ways for dealing with a bunch of the existing existing types in Kubernetes. And so instead of actually dealing with raw JSON or YAML or what have you, it actually has fully typed types that it actually deals with. But then it comes with a bunch of other really useful utilities that make it good to do things like controllers. And so the biggest thing that it does is it has both the ability to do a watch on something, which you can kind of see, that's how this thing actually learned. As I run new pods, I can actually see this stuff get updated. And so it runs that watch so that the program gets notified as soon as possible when something changes. But then the other thing it does is it actually keeps a cache of the state of the objects that it's actually seen from the server. And so what that means is that if you want to say, hey, what are all the pods that are running right now as you're doing computations for your controllers, all that stuff is in memory and it reduces a lot of the load on the server. And so it's essentially a way for you to keep your own private sort of mirror of the parts of the Kubernetes API that you actually care about. And so that's one of the things that we're using. And then there's a bunch of utilities for being able to actually write controllers in a responsible way. We're not going to be using it now, but one of the things that you'll see is really a best practice as you're building a controller is anytime you're going to write back to the cluster, you actually put it through a sort of a rate limited queue so that you're not actually pounding, because a lot of times what you'll see is that activity in a Kubernetes cluster is really bursty. You'll see a bunch of changes. And then you'll want to react to those changes, but you don't want to necessarily really pound the server really hard because that's not good. So instead, you actually put the changes that you've seen into a queue. That queue can collapse items if you see a whole bunch of changes on the same item, and all you need to know is hey, this thing changed. And then as you deal with that queue, you can rate limit the sort of how hard you hit the server to react to things changing. And so that's some of the basic things that actually come with the Go client. And so it's really more than just being able to make those RESTful calls. It's really sort of a toolkit for building controllers, and that's the right way to think about the Go client. Some of the other clients for other languages aren't quite as advanced here. So Andy says, who's really kind of more of an expert on this than I am, who not really he is more of an expert on this than I am, says, also I believe the event handler notification delivered in the same Go routine as controller run, whereas with the queue you can have worker Go routines. Yeah, so that's a good point. So you'll see later the way that I'm doing it, I'm reacting to things directly. So if I take a lot of time to do stuff, I can actually back some stuff up, whereas you can actually sort of use Go routines to actually shard things out to a bunch of sort of parallel workers if you go through that sort of queue pattern. But for simplicity's sake, we're not going ahead and doing that. Okay, so let's go through a little bit of the code here. So what I'm doing here is getting to the, so this is actually, let's see. So this code here is saying which kube config should I be using. And so I can either pass it in as a flag, or I can pull it out of the environment variable. In this case, I'm pulling it out of the environment variable. It's the same environment variable that kube control uses. And then the next thing I'm doing here is I'm creating this config for the RESTful client, which is essentially saying, go ahead and parse the kube config. And there's two different modes. If we actually know where the kube config is because it came from a flag or whatever, then I just say, hey, build it from flags, here's the thing. Otherwise, there's this special method here called in-cluster-config. And this does some magic stuff so that if you're running a controller inside of a cluster, it uses the service account that gets set up by default for everybody. And so whereas I have to make sure, let Let's see, it says we are not, YouTube just said they're not receiving video data at a fast enough rate. Let me apologize here for a second. Output. I should be sending it. Okay. If y'all can't see it, let me know. Hopefully things are still working here. YouTube's not happy. Like one of the things I want to get with my setup is a wired controller here. Okay. So Ruben says everything is looking fine. So, okay, maybe YouTube's just freaking out a little bit here. Okay, so the, oh, you know what? It's probably, I'm not moving stuff, and so it's probably all upset because the video compression works too well. Okay, so then, so this actually goes through and parses the config, and then it says, you know, create a new client based on that config. And so we're getting to the point where we have this thing here that lets us talk to the cluster. So that's good. And then we're doing two more things here. So we're creating this shared informer. An informer is that thing that both, and I'm trying to remember all this, and Andy, you can correct me if I get this screwed up. An informer essentially keeps that cache, that mirror of the objects that you care about, and it actually notifies you when things change. And we'll look at the code of what it looks like to use an informer next. The shared informer thing is something that's been happening over the last couple of releases. It used to be, so inside of the Kubernetes control plane, there's this thing that's the controller manager. The controller manager has like a gazillion of these controllers running in it, and they each actually kept their own mirror, and sometimes they were actually mirroring the same stuff. And so that was actually very memory intensive for large clusters. The shared informer is this architecture where, you know, if a single process is actually, you know, monitoring all the pods, that can actually be shared across a whole bunch of controllers. And then we're creating our controller, we're starting the shared informer, and then we're starting the controller. So let's go ahead and look at the controller here. The controller is a, and this is for pods is what we're doing. And so we have a getter, which is essentially a type safe way of actually getting at the stuff that's that cached view of the world. We have a lister, which is a similar type of thing, but I don't know, Andy, what's the difference between a lister and a getter? I think I'm a little confused on this stuff. I got to be honest. I always get a little, I think maybe the getter actually goes directly to the cluster, whereas the lister is actually viewing it from the cached version. And then when we actually set this thing up, we actually set this, okay, yeah, so the getter is actually hitting the client directly, whereas the lister is actually going through the informer. Yeah, so the lister is actually hitting the cache. And then there's this function that we can call saying has synced that actually when you first start up, you want to make sure, oh, things are getting a little jumpy here. That's not good. I think as VS Code actually goes through and tries to compile stuff in the background, let's see if we can turn some of that off. It spikes my CPU and build on save, off, lint on save. We'll do the lint. Yeah, so folks are noticing lag. I think it's the build on save. Is there a test? Actually, go test. Test on save is false. Okay. So I think it's just the build that's actually getting us here. Hopefully, I'm watching my CPU spike up over there. Okay. So hopefully we won't get some lag there. This is those things that you only discover after you start broadcasting, right? And so we're setting all these things up, and then we tell the informer that we want to add some event handlers. And this is essentially saying, hey, anytime you actually see an add, an update, or a delete, call these functions. And then, yeah, things are still slow. This is not cool. This is not cool. What is taking all my CPU? I'm going to try and figure out what's actually hitting the CPU so hard. I apologize, everybody. Yeah, it's getting laggy. Stop it. Lucky number 7 here. CPU, let's pull up. Oh, you know what it is? Freaking. I think I was running Docker in the background. I don't know what Docker's doing, but it's doing stuff. So let's quit Docker. We'll bring that back up if we need it. All right. I think that's better. Yeah. Yeah, Ruben's asking, am I running Minikube or VirtualBox? I was actually running Docker in the background. We'll have to like turn Docker back on, but for now I'll turn it off. And I think I have it set up to use all the CPUs available on the machine. We'll probably turn that down a little bit. All right, and then so all we're doing when we add is I'll explain sort of like what we're doing, but we're essentially saying on add. This meta namespace key function, it sort of looks at an object and it grabs out enough stuff that you actually get a good key for a queue. And so that's basically with pods, it's the namespace plus the name of the object. So you combine those and that becomes like essentially your key to the queue when you want to collapse stuff in a queue. So now we're to the point where we actually have this stuff reacting. We're doing the add, the update, and delete. We get notified about this stuff, and that's great. And then when we run it, what we do is we wait for the stuff to get cached, and then we go ahead and we start stuff. If you're doing a queue type of thing, what you would do is you would load up the queue before the caches are synced, and then you would actually start running your workers. And the reason that you want to do that is you want to make sure that if you're actually viewing back into the cache to make decisions, you want to make sure that you actually have all the data that you need to make the decisions. So that's another thing that you get with the queue is that you get to delay stuff until you actually have a consistent-ish view of the world in your cache. Is the lag improved, guys? I think so. It looks like it from this end. Okay, so now let's start writing a controller. So I had two ideas for a controller, and if folks have other ideas, we can go ahead and do that. So the first idea that I had, I was talking to somebody, and they were setting up a Kubernetes cluster for a bunch of developers to use, and they were doing something like a namespace per developer, but then they had secrets for, like, say, the shared database that maybe wasn't running on the cluster for development that everybody was sharing, and they wanted to actually propagate these secrets into all of their developer namespaces, right? So we could build a controller here that watches sort of an example namespace, grabs all the secrets out of that example namespace, and then pushes those to a bunch of other namespaces and creates duplicates. No, I got beer. So Parthaman is asking where the beer is. I got beer. Don't worry. I'm good. There we go. So it's a sort of a secrets distribution controller, and you can see how this pattern of might apply to config maps also. Now you can access config maps across namespace. I don't know if you can access secrets across namespace. But even if you can't, this idea that I want to sort of take an exemplar and then sort of like create duplicates in a bunch of namespace, that's kind of a fun thing to be able to write. And then we can do things like if you create or delete new secrets, they automatically get pushed around. And then the other idea that I had for a controller was an auto service controller where we monitor deployments, and anytime you launch a deployment, maybe if it has a certain annotation on it, we automatically create a service to actually point to that deployment. So a lot of times you find yourself saying create this deployment and then go ahead and create a service to go along with it. Well, maybe we can actually go ahead and do that automatically, maybe based on an annotation, or maybe we just do it for all deployments unless they have an annotation, something like that. I don't know if that's a good idea, to be honest. It's possible. I think it kind of shows that with controllers like this, just because you can do something doesn't mean that you should. But I think it's kind of an interesting sort of like, can we actually make deployments also be services and sort of like hide the detail of the service from users if they don't want to. So quick straw poll, like, do you think the secrets distribution or the sort of auto service controller is more fun? Which one looks more interesting? And we may not make it all the way through in this. I'll see how far we get, but I wanted to at least sort of set the stage for this. No? Nobody has any ideas? Or are we just like dealing with lag? Have you all dropped? All right, well, let's see. All things being equal, let's go through and the secrets. Okay, Ahmet says let's do the secrets one. Okay, Pratik says the auto service one. Eddie says secrets. Let's see, Shiner says auto service. Okay, you guys are not helping me here. Burn says secrets, auto service. I think we're one ahead on secrets. Let's give it a few more seconds here. So we have auto service for auto secrets. Let's do the secrets. I'm going to do the secrets because they're going to be a little bit faster because we're only going to be watching one set of objects, which is the secrets. We're not going to have to actually... You can create a controller that actually has an informer for 2 types and actually monitors 2 types. But with the secrets, we only have to actually manage one. All right, so the first thing we need to do is let's turn this from a pod thing to a secret thing. So we have a secret getter, secret lister synced. This is, so secrets are part of which API? Oh, I always forget this. Kubernetes API. Let's figure out which API group it is. So I always find here, API versions. This thing, y'all know where this is. You've sort of like found your way to this if you're dealing with the API. Okay, secrets is part of core. Okay, so I don't have to actually change that stuff up. Okay, so we have core v1, lister core v1, pods, so this would be secrets. We're going to go through, this is going to be secret informer, secret. I can probably do a find and replace, but I always... I think, lister, secret informer, add these, boom, boom, boom. Run, not doing anything here. The on add. Okay, so none of this stuff is actually super specific to the secrets. Okay, so I think that's good there. And then here, I'm getting pods, but I should be able to do secrets. So if I did everything right, and let's... So let's see if we can go run here. Oh, undefined. Core 1, secrets lister. Oh, you know what? This is actually confusing. So the listers are named after the non-plural type, and the getters are named after the plural type. So that is like one of these gotchas. Okay, so I missed it on line 46. And if I were a better developer, I would have all this integrated with VS Code, but I'm old school. Okay, look at that. Okay, we got a bunch of secrets. That's great. That's actually really great. Okay, so one of the things you'll notice here is that every single one of the every namespace is actually going to get a default service account token, which is something that we're going to see, and we probably don't want to synchronize those. So one of the things that we can do here is that we can do a kube control. Oh, so we signed a deal, and so you notice that the gong's not behind me today. I think they're about to hit the gong out there. It's going to be a little loud. Hopefully, I think we'll probably hear it in here. So I can do kube control get secret. And then let's look at the default token here for the default namespace. If you look at this, one of the things that you'll see, there's a whole bunch of stuff here. You could probably hack my cluster if you looked at this. And what we'll see is with secrets, there is a type here. And so this is Kubernetes.io service account token. Is the type of the secret. So there's actually sort of like a subtype of the kind of the secret so that you can have different types of secrets. I think if we actually do, if we do this, okay, yeah, you can see the type there also. So let's go through and, okay, so thanks, John, for the congrats there. I don't know, it hasn't happened yet, They're all milling about, making noise out there. I'm kind of scared. It's going to happen any second. But let's go through and let's define a constant. And we're going to do, all right, secret sync type. And we're going to call this, okay, Pratik says, sorry I joined late. I might have missed it, but I really want to get your views on the cache controller run stop channel method. It doesn't return any errors. Isn't it a problem for long running controllers? Generally, you want the controllers to actually just run and run and run and run. And if they hit errors, you want to log. You probably like you either deal with the error or you pass it up to something else and let it deal with it. At the top level for a daemon controller like this, you probably want to do your best not to actually exit out and just to keep going. So by the time we're actually running the controller, we really don't want the like what would we do if the controller returned an error, right? Would we go through and oh, there's cheering out there. Would we actually go through and like fatal exit or error out? Probably. Oh, yeah, there it is. Did y'all hear that? It's really loud. So would we actually go through and actually error out of the controller, or would we? Okay, so in case of network outage, you'd want to reconnect. Yeah, I think I believe that the client Go, in the case of a network outage, will keep trying to reconnect itself. It tries to actually keep itself going. That would probably be in the informer that you would actually see that stuff happen. Oh, one of the things that we didn't actually cover here is that there's this parameter here in the informer. I set it to 10 minutes. I think by default in a lot of cases it's actually, oh thanks John. A lot of times people will set that to infinite or 24 hours. This is like how often do you want the informer to say, you know what, maybe somebody got confused. Let me actually just go through and actually relist everything that I'm watching just to make sure that everybody gets poked and actually sees. And this is like the difference between an edge triggered controller versus a level set controller. With a level set controller, you want to try and just sort of like deal with the world as it is. And so if you repeat and even sometimes repeat for just robustness sake, notifications, everything should be idempotent and you should be good. Whereas if your edge, so Ruben says that, yeah, I'm in the right place for the gong hit because it's like incredibly loud out there. But if you're doing sort of an edge trigger thing and you're actually sort of watching every little state change and acting on that instead of sort of like what the new reality is, then if you miss one of those or if you get a duplication, it can be a real problem. And so all the controllers in Kubernetes are level set. So if you hit connection problems, you'll do a resync. And you'll sort of like go through and like, you know, check the world again because something might have changed when you weren't watching. But it's, you know, the way that we're going to write controllers is actually safe to be able to do that stuff. All right, so we're going to go through and actually I think these names have to start with, they can't start with a 0. Okay, so I'll just do like bedafamily.com, or I'll do my blog 80%.com. Net secret sync. Okay, so that means that every time we actually see a controller that's of that type, we're going to want to sync, and secret sync source namespace equals secret sync. All right, we're going to be watching for all the secrets in that particular namespace. Okay, so now let's see if we can actually run this. Okay, we ran that already. It was watching for it. So the first thing we're going to want to do here is we're going to want to, let's see here. How do we want to do this? So what we can do is we're going to create a single function here. Handle secret change. And then we're going to do this on the object. And that'll be the new object. And so instead of actually, so now we're actually going to call through and we're going to do c.handle secret change on the object. We're going to do that here. here, and here. Now, this is the old object. We have the new object. We're going to actually pass the new object in because that's the one that we actually care about. And then it'll actually do it. Now, like astute readers will actually notice that there's a bug here already. And so one of the bugs that I actually have is that I'm actually calling this on delete. And that's an edge trigger thing because if all I'm doing is actually going to be keying off of what's happening with the source secrets, if I had a problem where my controller wasn't running, a source secret got deleted, and then my controller started again, I wouldn't get that delete notification, and I wouldn't know to actually go ahead and delete it from all the other namespaces. I'm going to leave that for now. We're not going to quite get to that, but that's one of the reasons why you want to actually have maybe in a periodic sync, you want to actually go through and really evaluate the world. That's not something that we're going to see as we view each of these changes. We're actually going to see it. We're going to have to maybe do something else to actually evaluate the world there. Okay, so let's handle a secret change, and then I can do. Let's do obj dot. Okay, so there's a gotcha here that I'm trying to remember. If I go to the definition of meta namespace key func, I think that actually shows me what's going on here. This actually goes through meta, blah, blah, explicit key. Okay, so I believe there's a lot of times when you get a delete, sometimes you'll actually get a delete and it won't actually have an object in it. It'll actually pass you a different type. But let's actually ignore that for now. Hi, Jack. So let's go through, and what we're going to do here is we're going to cast this to a secrets object. Okay? And so secret, okay, equals obj dot, and this would be core v1. Am I forgetting the secret? Yeah, delete final state unknown. Okay, so there's some subtlety there. Andy can actually put an explanation in the chat because I'm not smart enough to remember this stuff off the top of my head. Okay, so this is core v1 is the typed thing. I actually want the API. So Gates.io client go Kubernetes is it package? Where is this? Is this package API? All right, now I'm gonna have to. Okay, so Andy says would give you the informer's last known state of the object since it has been deleted, but you actually can't see. You didn't see the actual delete event. So if the informer didn't catch the delete, it can send you one of these things saying, hey, we think this object went away, but we're not sure exactly what the last version of it looked like. All right, so I'm going to start up because I always, this is where I am not as familiar as I probably need to be with the client Go stuff. I'm going to start up another editor window here. And we're going to find API types.go. It's in package API v1 is the one that I want. Okay. So client go package API v1, and we're going to call this API v1 core v1 is what that thing's going to be. API core v1 dot secret. And then, so there I go. That's good. And that's the right. Oh, did I actually close something on accident? I think that's the right cast syntax. I always get confused with Golang casts. If not okay, then I'm just going to go ahead and return because we saw a delete, but we're not sure what happened. We maybe can deal with that later. Let's put a to do there. This is probably a deleted final state unknown. Figure out what to do. All right, so there we go. We're actually looking at that. Oh, you know what? I am going to actually have another informer around namespaces. So let's go ahead and we're going to have the, we're going to need to actually watch namespaces. Namespaces. A pointer to a secret is what Andy says. Okay, so I had that wrong. So down here, I want to go to a pointer to a secret is what that thing is. Yes, you guys are way ahead of me here. You should help me do this all the time. So we're going to go through there, and then we're going to say if secret dot, let's see, object meta dot namespace does not equal secret sync source namespace. Then I want to return, and then maybe I can do a log printf skipping secret in wrong namespace, and then I can do an if secret dot object dot type does not equal secret sync type. Then I want to do log dot printf skipping secret of wrong type return. Okay, and then I'm gonna do log if do something with this secret. Let's go ahead and do that. Now we have something similar here where I was going to do the thing with the namespaces, because we want to actually duplicate everything when we have. We want to duplicate everything whenever we're getting a new namespace also, because like whenever I add a namespace, I want to propagate the secrets to the new namespace, similarly to whenever I get a new secret, right? And then I also want to use the namespace cache so that whenever I get a new secret, I can actually rip through all the namespaces and figure out which namespaces I want to actually create or update secrets in. So I have to get that stuff up and running also. What we're going to do here is we can do namespace is, well, not namespace is, let's do namespace getter. Getter is client.core v1 dot, yeah, that'll actually be the same thing, but we'll just do that so that it's okay if it's a duplicate thing. Is lister equals namespace informer dot, and let's go through and informer core. Lister namespace lister synced informer dot as synced. Okay, so we got all that. When we run here, let's go through and we can do namespace. Does this thing actually take more than one? Oh, look, I can give it a couple of them. That's nice. So I don't have to duplicate that. It would have worked, but there we go. Okay, we're not going to set up the event handlers there for the namespace yet. We just we'll do that eventually, but for now we'll just go ahead and do that. And then I have to go back to the controller here, and now this thing is taking shared informers.core.v1.namespaces. It takes a splat, yes. And is this thing mad at me? It's running. My CPU is being hit pretty hard here, but I think the stream is mostly catching up here. So, all right. So I'm gonna get an error. What do I got? Undefined namespaces lister. That's not names. It's namespace lister. This thing caught me again. Andy, why is the lister singular and the getter is plural? That's killing me. Okay. Yay. Okay. So here what we see is that as we're actually coming in, it actually says caches are synced waiting for stop sync, and it's actually we can see that it's skipping all the secrets in the wrong namespace because we haven't actually created that namespace yet. So that's cool. So let's go ahead and do that. So we can do cube control. Is that create namespace? Does that work? Yeah, and then I can like give it a name. And what do we call it? We were going to call it secret sync. Oh, I probably don't want it to be. Let's do that so that it's all lowercase. Secret sync. So now we have that, and then let's create cube control, create secret, namespace equals secret sync. I always forget for this. And we'll do, oh geez, okay, so generic. Can we set the type? Or is cube control failing us? From literal for setting secrets. Can we actually set the type here? Or is this going to be annoying? It's going to be annoying. Oh, type, yes you can. Okay. And we can do from literal equals foo equals bar. Type equals, and then we're going to do this. Name is required. Oh, generic. Let's see. We call this super secret. Secret, super secret is created. Okay, cube control. Get secret. Namespace equals secret sync. All right, there we go. We got our super secret there. So that's up and running. Let's run our controller again here. And we're going to see a lot of junk, but at some point we should see super secret. Oh, it says skipping secret of wrong type. Oh, that's the, oh no, that's the, okay, that's what we wanted. So, because that's the whatchamacallit, the service account token. But here we have do something with this secret. So that's what we wanted. So we see secret sync super secret. It says we want to do something with that secret. Okay. So now what we want to do here is I'm going to do something stupid here. And I'm going to go through, I'm going to do for, let's see, we want to go through and we want to list all the namespaces. So we can have our namespace lister, and this will actually hit a cache. Oh, we want to do c dot list, and then okay. So this always confuses the hell out of me because we have to give it a let me look in the Kubernetes code here because I always forget the syntax for how you do this. GitHub. And I know I wrote a controller for doing bootstrap secrets. And so I know where that is. Controller. This is the source graph plugin. It starts doing this sidebar thing that's really useful. I think that's the one that's doing it. You can collapse this. So we have Bootstrap. So we have this Bootstrap signer thing. Okay, labels.everything. Okay, is what, yeah, so I think we pretty much want to list, we list all the namespaces. At some point, what we may want to do is we may want to actually only sync to certain namespaces that have a particular label on them. Labels.everything. If I do this, will I get the right import? Which import did I get? Something, labels. Yes, API machinery package labels. So we got the right thing there. Okay. Labels.everything should do it. All right, and so then this returns something. Does this return the list directly, or does it return another object I got to crack? So it returns an array and an error. Okay. Array of namespaces and errors. Okay. Namespaces error equals this. If error does not equal nil, then we'll do log.error print. Yeah. Error listing namespaces. And we'll just return. So this is actually not as bad as it looks here to actually go ahead and return. You definitely want to track these things, and this isn't a great situation. But a lot of times when you hit these transient errors, you might know that there's going to be another notification coming. Or if worse comes to worse, if you're being really sloppy, you can rely on this resync period, which means that you'll try this again every 10 minutes when you actually resync everything. That's not great. And it's inefficient, and it's gonna like give you unpredictable behavior, but it's part of the sort of like eventually everything can kind of settle and come together. But this is the type of thing that if you're building a production system, these are going to be like the type of errors that you're going to want to track and try and track down, because you may miss it every time, or it may just slow down, and like you may get reports from users going like, I do this, but sometimes it takes like 10 minutes for things to sync. And it's like, well, why is that happening? Well, maybe there was some sort of error the first time around. And then I do for and we'll do log.printf. So we should copy s2 namespace, and we'll do secret dot object meta dot name, and then the namespace is namespace dot object meta dot name. All right, so what we should be doing here is every time we see one of these secrets, we'll go ahead and we'll do that. I should probably switch to a logging library that has different levels, because we're actually getting a lot of junk here, but let's go ahead and see what happens here. Okay, it says do something with this secret. Did we do something with this secret? Did I not save? There we go. And then it says, and then I saw nothing happened. I was expecting that I would actually see a bunch of these sort of like, we should copy blah, blah, blah. Now, the reason why I'm probably not seeing that is because I'm not using a queue, right? And so I'm still waiting for all of the caches to get synced. So that's probably why this isn't happening. So if I actually put this stuff on a queue, that queue would only get started processing after all the caches are synced. So that's kind of bad. I don't want to add the queue right now because that adds a lot of code. So I'm going to do something really bad. I'm going to use the getter instead of the lister. And the getter actually says don't hit the cache, actually hit the live API server. So I'm going to do namespace getter. And let's go ahead and run that. Oh, getter list. Okay, did I do something wrong here? What did I dot? What is available? Namespaces dot. There, dot list. Okay. And the getter is actually, it's called a getter, but it's really sort of a REST client, so it's actually hitting the stuff directly. Okay, now it says labels is not, it doesn't like labels there. So cannot use labels.everything as type blah, 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 list options. Oh, so this is fascinating. The API for actually hitting the informer is different. So now I have to do, this is going to be, it's going to be like a meta v1 thing. What was that type? It was. Oh, darn it. And then I can do dot list options. Is that going to be good enough? You think that'll be good enough? What isn't a list option? Let's go to the definition of this. Yeah, I don't do this all the time. Somebody who did this all the time, they would be like boom, boom, boom. So you can set the label yeah, so we don't need any of these. Include uninitialize. Oh, this is a new thing. Resource version. Okay, we don't need any of that. So we just have to pass sort of like a blank list options there. Does it need a pointer to those? And it returns a namespace list. No, it takes one of those and it returns a namespace list, which is an API object in and of itself, and an error. Okay, and then I want to go through list.items. All right, let's see what happens here. Andy's. Okay, so yeah, so Eli's asking how stable are these APIs that you're importing? Actually turns out really stable. Like this will work against, you know, the code that we're writing now should work against Kubernetes clients because we're using just the core v1 APIs. There's no beta, there's no alpha anywhere. This should be very stable moving forward. All right, yes, okay, great. So now what we say here is now we have this thing and it says, oh, we should copy super secret to namespace default, kube public, kube system, and secret sync. That's great. We probably don't want to copy it to kube public or kube system. So let's have a blacklist here. What we really want is a set. And we can do, but we don't have a set in Go. So we'll do var namespace blacklist equals, oh God, how do we, I can do a map of string to bool, and we'll do this, we'll initialize this, so we don't want to do this is like a, well, I'll do secret sync source namespace. This is like a poor man's set here. And then we'll be like, and then here, what we'll do is say, we'll, I should probably break this up into some smaller functions, but let's just splat it out right now and see what we're at. If, secret or namespace, we'll do namespace name equals ns.object meta.name. We'll do if ns name if and its name. So if we found it, then I'll do a log.print skipping namespace. All right, thanks Andy for hanging out, man. Names on blacklist. And I'm going to run out of time here too, and we'll have to pick this up again. Maybe I'll do some more this weekend, do a sort of off hours type of thing. Unfortunately, I'm traveling, though I may not be able to do that. So now we'll actually go through and we'll skip this. If we do this, we should copy. Oh, I forgot to actually do a return here. Yeah, so go ahead and run this again. And what we should have here, yes, we should copy super secret to namespace default. That's the one that we want to see. Yeah, so that's interesting. We're good. And what we see is some of these ads actually came after the caches were synced. I wonder what was going on there. Okay, so that's going on. So now we're going to actually copy it. And so now what we'll do is we'll write another function that says copy secret to namespace. And then we'll have the secret. And then we'll have the namespace name. Right, let's create a function here. C controller copy secret to namespace, and we're going to have we're going to have the full secret that we had before, and so that type here is going to be an API core v1. Brother man, thank you. Yeah, I think, this is more than you can fit into an hour, but hopefully this starts giving folks a little bit of an idea of what this stuff looks like. And I think maybe we can work through this over a couple of sessions, and it'll be kind of fun. Let's see, API core v1 secret. That's not. And we want to have as a pointer, and then we're going to have a NS name string. And then what we'll do is, yeah, so a CRD would actually be really useful, and that's the help that that Andy's going to be writing. So yeah, so I'm going to leave it off here. What we're actually going to do here, I'll put it to do here, to do, and we're gonna need to make let's see. Make a deep copy of the secret. So one of the things is that when you get these things from the informers, they're shared informers, so you shouldn't modify that object directly. It turns out that this is something that, like, having a const type in Go would be really useful here. But we don't have that. I believe there's some checks in there to make sure that people don't accidentally modify objects. So we need to make a deep copy of the secret. We need to remove things like object versions that'll prevent us from writing. And then we'll go through and we will go through, remove the things like the object version that'll prevent us from writing. We'll write in new namespace, and then we'll do a create or update for the new object. So that's what we're going to do in this function. Do I want to continue instead of return on 136? Yes, I do. Yes, I do want to continue there. Good catch, Alexander. Thank you very much. All right, so the idea here is that we're actually copying this thing to the namespace, and that's really useful. One of the things that you'll see that I'm doing here is that when I get a secret change, I'm actually going through and actually seeing, like, what happens if I take that secret and I, oh, and my thing is stuttering out again. What happens if I take that secret and then modify it, right? But then, like, we have to deal with the case of what happens if I add a new namespace. Then we have to deal with the case of what happens if I want to, like, do a pass to make sure that I don't have any secrets that are in a namespace that I don't want to actually have in the source namespace, right? My source namespace, right? And so really sort of like, it's a little brute force, but it's not as crazy as it sounds because we have these caches, is what I could do is I could actually go through and look at all secrets and all namespace. Every time I got a poke to say, hey, update this secret, I could just go through and update everything. Look at all the secrets, look at all the namespaces, and push everything out. And that means that I'm writing one function that says, look at the world depending on how I have my caches. And as I look at that world, go ahead and update stuff. And so that's probably the right way to do this. What we probably want to have is one handler function that runs a single function that actually sort of reconciles everything. And it's sitting there waiting for a, to be triggered. And when it gets triggered, it goes ahead and does its thing. But I think that's a little bit more complicated to get up and running. Maybe I'll do that, some other time and then fill everybody in on the details. In terms of TGIK, I am going to be on vacation for like the next 3 weeks, so I won't be doing these for the next 3 weeks. And this is definitely the type of thing that I want to pick up when we come back. I'll probably find some time to do a little bit of coding offline. And then maybe we can actually go through and run through sort of what a little bit more bulletproof version of this code looks like after you take some time to actually fill everything out. So didn't get quite as much done as I wanted to in this particular session. But thank you everybody for tuning in. I really, really appreciate it. Hopefully it was kind of interesting. You start seeing how controllers work, the idea of sort of level triggered versus edge triggered. And start thinking about how we can write code that's going to be really stable as these things come and go, as the controllers restart, things like that. So thank you. Everybody have a great weekend. And I will see you in like 3 weeks because, yeah, we're going to go camping. We're going to go big road trip, hit Glacier and Banff and Jasper, having a good time. So out with the family. All right, everybody have a good 3 weeks. And we will resume TGIK when I come back from my big old camping trip, assuming that I haven't been eaten by a bear. All right, see you later.